who I met while I was in grad school at Islandwood. And Bainbridge Island is a small place. So if you were in your 20s, you probably knew who else was there. And I'm really glad that I got to meet Kayla. She's really cool. So she is currently a graduate student at the University of Washington, earning a master's degree in forest resources, and originally from the town of Forks, but grew up on Bainbridge. So she experienced two different perspectives regarding the forest, from different cultural areas, I guess you could say. She comes from a long line of foresters and has worked as a forestry technician in both wilderness and urban settings for organizations like the UW, the US Forest Service, the Washington State Department of Natural Resources, and Puget Sound Energy. And right now she's about to start a new chapter in her life as she finishes up grad school and heads off to a new job, working as state lands forester for the DNR. And so tonight we will be introduced to some forestry ideas and lingo, and we'll get a sneak peek at some of her work from grad school. And I personally love learning from trees about trees from Kayla because of the newer ecological perspective that she is infusing into the practice of forestry. And so we're going to hear a little bit more about her adventures in the trees. And, I'm sure she'll tell us all why she thinks trees are important, but there's just a little blurb that I got from her, which was a very long list of reasons why trees are important, but some of those reasons include their role in mitigating global climate change and climate regulation, that they can provide reliable jobs to folks in rural communities, and that a stand of trees is a peaceful spiritual sanctuary where people can find themselves walking in the forest. So I think we will have Kayla share her screen and get started on her presentation, and I'm very excited to see it. But I think, Kayla, do you have screen? Yes, you do. Okay.
All right, can you all see this pretty well? I'm gonna try to put it in a slide. Hopefully I can present it. I wonder why it's not presenting. There we go. All right, we good to go? Awesome. Hi, everybody. I'm Kayla Swerin, and I am currently on Bainbridge Island. I grew up most of my life here and originally come from Forks, Washington. You guys have probably heard of it or maybe driven through out to visit the beaches or the Hoh Rainforest. And I'm going to talk to you today a little bit about forest dynamics in Washington and kind of my role as a forest steward in Western Washington. So I will get started. And I want to say this is a shot actually from the Elwha River after the dam was removed. And I thought that was worth noting. You get to see Mount Olympus in the background. It's a nice little shot. All right, so I'm going to start off by talking to you all a little bit about forest stand dynamics in Western Washington. Some of you are probably familiar with this, so I'll try to keep it brief. The forest type most common in this side of Washington state, or the predominant forest type, is the Douglas fir Western hemlock forest type. There's various stages of growth following disturbance, which can be natural or human caused. And the periods in which these stages occur usually vary depending on soil productivity and just general site conditions. The first stage is what we call the stand initiation stage, or the early seral, early successional cohort establishment, or pre-forest stage. And this stage is usually characterized by high species diversity, lots of shrub species and forbs typically. Some may even argue that it is the most diverse stage in forest development, which is kind of neat. It also provides a lot of foraging habitat for ungulate species and other animals, mammals in particular. There's high nutrient cycling in this stage, as well as nitrogen fixation by red alder typically, as well as some other shrub species. And these conditions may persist for decades depending on seed abundance. And again, this ties back into the site conditions of a given area. So it can vary. Stem exclusion or canopy closure stage or the young forest stage is when intertree competition cause mortality happens. So when all the trees are trying to grow up to the light and the canopies close off, you have a very limited understory component. Biomass accumulates because trees are being outcompeted. So you usually see a lot of dead matter on the ground. And it's considered to have the lowest biodiversity of the stages. The third is the mature stage or the understory reinitiation stage. And this stage is characterized by more light and moisture reaching the understory or the forest floor. There's a lot of agent-based mortality that occurs in this stage, usually from diseases coming in, common ones being root rot. So this forms gaps in the canopy. There's also a bunch of spatial heterogeneity that happens in the stand. So it's a little more complex structurally. There's all different sorts of levels to the forest. And again, understory species really start establishing because they have access to these light and moisture conditions. And then the last, which we're all very familiar with, especially if you've been out to the Hoh rainforest, are these old growth conditions. They are the most, forests in this stage are the most functionally and structurally diverse. There's a lot of live and dead trees mixed in, a much more heterogeneity or variability or diversity, if you will, in this type of forest type. Very biodiverse as well, just kind of like that pre-forest stage. But you're seeing most of the diversity in the structural and functional components. Biodiversity or species composition or richness usually comes in the form of like fungal and arthropod species. There's a lot of shade intolerant species that are released and have the ability to grow up into the canopy at this stage, such as like western hemlock and red cedar. And this diagram on the right kind of gives you a little bit of an idea of how that plays out on kind of a generalized timeline. Disturbance in the area, you guys are probably familiar with wind. We see a lot of it. I'm sure the Friends of the Forest see a lot of blowdown, especially in the winter time. So a lot of there will be a lot of wind events, stand replacing, or events where the wind blows down huge sections of forest. They occur generally anywhere from like 20 to 35 years, kind of depending on proximity to the coast. A lot of species that you'll see released in these sort of climates are more shade tolerant, so hemlock and cedar. And then you have fire, which is another disturbance that does actually happen in Western Washington. I know it's not as common as on the east side, but the interval of return for fire, stand replacing fire, is anywhere from about 300 to 500 years, but sometimes it's up to like 1,000 years in some parts near the coast that scientists have not been able to find any fire record for to this day. So it really just kind of depends on how far into the interior you're located with regard to fire interval. Disease, we've got root rots, other fungal pathogens that attack roots and heartwood of trees, bot rots, which generally happen in older trees, older conifer. We've got snow and ice damage, anthropogenic damage or disturbance, generally caused by things such as logging or human-caused wildfire, that sort of thing. And then, of course, the climate effects kind of tie on into all of this. You have kind of this natural side of the effects of climate change, and then you have the human-caused, which all tie into potentially causing things like increased drought or even fire intensity or frequency. I just want to kind of go over some of the traditional forest management in Washington, which a lot of you are probably very familiar, which is clear cutting or even age stand management. So even age management, you clear the landscape and you just plant the whole landscape with trees that are the same age, and generally they're pure species stands or mixed species stands in Washington. Maybe like Doug fir, Western hemlock, or Doug fir, hemlock, cedar. Those are common mixtures. Clear cuts are usually artificially regenerated, so people come in and plant them, except for on the edge. You can see in this photo on the top left, the forest line here, you know, that could be a useful seed source kind of along the edges of clear cut. So sometimes there is natural seeding, because winged seeds from conifers do tend to travel in winds pretty far, up to 3 miles for some species like larch. which is on the east side. We also have shelterwood and seed tree systems, which do promote natural regeneration. The shelterwood systems, they usually leave a bunch of trees on the landscape to provide shelter for more shade intolerant species, or excuse me, shade tolerant species. And then seed tree regeneration is there just to promote, again, more natural regeneration. But the thing is with those systems is those trees are eventually cut and they do not stay in units or stand units in perpetuity. And of course, there's impacts associated with clear cutting, such as to hydrological systems, usually not as much in Washington compared to other places because there's such stringent stream and riparian or wetland regulations in place. So we're pretty good about that here in the state. But, you know, it does fragment the landscape, which can be detrimental to certain species that depend on continuous forest cover in order to either forage or nest, so usually bird species. And then erosion can be an issue too. And there's been some problems with that. If you guys remember the OSA slide that happened years ago, I believe it was in the early 2000s. So there are some things that can come of this that aren't particularly good. These two books at the bottom of the screen here are books that are generally given to forestry students like myself in learning silvicultural practices in the Pacific Northwest. So if you're curious about that, I believe this is going to be available for you and you can check out these books if you're interested. Kind of a newer mode of thinking that's emerged in Washington in particular is this idea of ecological forest management. Where the idea is when you harvest, you want to kind of try to mimic local disturbance regimes. So like with wind events, the stand will not be completely blown down. There will usually be legacy trees, such as seed trees or snags, which can provide habitat or, you know, seed crops for regeneration in a certain area. So by following this ecological process, there's a couple of different systems that have been developed. The more common and more new is the variable retention harvest, which creates essentially a mixture of small openings or gaps, which I kind of talked about start occurring in that mature forest stage. And variable stand densities start to occur in this type of harvest, which is obviously man-made, and it emulates this like these microscale disturbances that would occur naturally from not just wind, but like snow or ice events or disease. And then there's an uneven age management, which is selection harvest, which back in the day when settlers came into Western Washington in particular, you know, they were high grading, and high grading essentially means that they were taking the biggest, best trees from the system, which generally those trees provide a lot of ecosystem services. So there was kind of the shift in forest type as a result. And then of course, clear cutting came through. And after, I believe the 1920s, when the steam donkey was invented, or when the invention of the steam donkey came, excuse me, the invention of the steam donkey came along, and then harvesting became a lot more efficient. But essentially the selection harvest also kind of mimics the natural gap formation as well in forests as they age, and allows for understory species to emerge. Overall, the idea of this ecological management is really just to preserve ecological functions like biodiversity or biological richness, also known as species composition, as well as structure and function within forest types. And these two books at the bottom here are kind of newer. If you've heard of Dr. Jerry Franklin, he is one of the pioneers of this old growth movement, and he's in his early 80s now, and he's still partaking in all of these activities in terms of forest planning. He's even writing papers still. I mean, this guy is very dedicated, and he kind of helped pioneer this ecological forestry movement with Norman Johnson, who's down at Oregon State University. So I just want to start to talking about myself a little bit by talking a bit about my background. I come from a long line of woodsmen out in the Forks area, primarily, well, in Forks, but the Olympic Peninsula. And they, you know, when back in the early 1900s, when people were immigrating to the States to do logging and stuff like that, you know, they were coming to the Pacific Northwest because that's where a bunch of the big timber was. or and still exist, but that's where they can make a living and provide for their families. So my family kind of comes into, we have discussions about forestry and they're coming from more of like an economic perspective. I would say, let's see. So my great grandfather immigrated from Sweden in the early 1900s and started logging in Roche Harbor around Stewart Island, where he met my great grandmother Clara, and then they moved to Forks. And then my father's mother, her father came from Canada and worked for a mill for his whole life in Forks. So that's how my families on my dad's side came together. And then my dad's father, my granddad, worked as a silviculturist for Rainier Timber Company for about 30 plus years. My mom's family moved from Port Townsend in the early 70s, and my granddad worked for the Forest Service building roads for logging operations when they were still doing logging operations with the Forest Service. My mom's brother owns a logging company to this day. I had another uncle in the pulp and paper industry. I mean, there's a lot of woodsmen in my family, and it's interesting because I am the first woman in my family to kind of pursue this field. So that's been kind of interesting. I have good talks with my family to this day, and definitely lots of long conversations. So which is pretty neat. And I did want to include this photo just because it's the oldest photo that I have that kind of gives you all an idea about the size of trees that were being harvested around Forks during the early to mid 1900s. So this photo was taken in 1947. And on the far left is my grandfather, Johann Swerin. And he is pictured here with his fellow loggers next to this 9-foot diameter Doug fir that they felled along the North Fork of the Clawa. The Clawa River is the first bridge that you cross when you get into Forks, if you've been through there. And the tree produced about 40,000 cubic board feet of wood, which is crazy. You're not going to see trees. There's no mills that would even take trees like this, which in my opinion is probably a good thing considering there's not as much old growth forest as there used to be. And there's so much benefits to be had from promoting preserving old growth today. So, when I was about 6, my mother remarried and we came to Bainbridge, which was a stark contrast to Forks. I still maintain my love for the outdoors. I would go to Forks every other weekend and see my dad and my grandparents. So I kind of always had this love for the outdoors, but living on the island, being kind of a more, it's not as rural, it's more of a liberal community. I kind of developed this environmental perspective around forestry. And for a while, I was pretty ashamed of my roots growing up in this kind of community because I just didn't think people would like that I came from foresters or loggers because they've always been vilified or they're like the villains, of the area. So I kind of had this shame, but until I went to school and changed my major to a major in environmental studies after taking a class with Dr. Jerry Franklin, his old growth forestry class, where we read a lot of books about forks, and my grandfather was actually cited in one of the books that we read. I was just like, wow, I'm actually pretty proud to be from this area. And, there's something to be said for hard work, and there's something to be said for hard work when people put food on their, on the plates of, for their children and provide. It's just different. It's something that I kind of didn't really think about as like a teenager, and I had more respect for it. And so I decided I wanted to get this sort of major and go more into restoration. So I got an internship with the Stewardship Partners, who is based out of Seattle, and they do a lot of riparian restoration. Pictured here on the left is actually some of the willow stakes as part of my project that we restored this 300-foot buffer along the Snoqualmie River with. And this is me on the right here planting some Doug fir. We have a bunch of conifers in the area, and believe it or not, conifers do provide so many benefits along riparian areas, and that they provide shade. They're long lived. They provide nutrients and just overall protection for aquatic species. So that was kind of my first experience actually being a part of forestry in this way, I guess, and kind of more of a restoration aspect. After college, I think I might have been inspired to do wildlife studies, but after watching Planet Earth series. And so I tried out some wildlife apprenticeships, and it was an apprenticeship that I had working for some primatologists down in South America that I realized when I was down there, I missed the forest. I miss trees. This is where I come from. This is more in line with, I think, what is more comfortable with me. So I was actually like regenerated and had this passion kind of emerge where I wanted to go back home and work in the woods. So I got my first job as a forestry technician for a PhD student at UW up in Colville National Forest in the northeastern part of Washington. And basically, this PhD student who now owns who runs the climate resiliency chapter of DNR, he was trying to figure out these treatments that would be best in federal lands, because as you know, federal lands try to manage forests in a more ecological way compared to, say, private lands. So he was building a case for ecological management, and still kind of its like early days. So, but what we were doing, we were collecting spatial data, looking at patterns of residual overstory trees or like legacy trees that are on the landscape after, say, a natural disturbance comes in. And Derek was trying to mimic the patterns as a result of like windstorm or fire, and how to harvest in like federal land. So it was an interesting project to be a part of, and it kind of got me kickstarted into this field. After that, I was a seasonal employee with the Forest Service on the Chelan and Entiat Ranger districts for 2 years. And I was part of the timber stand improvement team. So still kind of in this restoration type of forestry. We would go in and conduct stand exams, which are basically you lay plots and you take data on species composition and forest health, age, height, and then and diameter of trees. And you find these distributions that tell you a story essentially about where the forest is at, so that you can develop restoration treatments appropriate for the area if need be. We would also do regeneration surveys in planted and in naturally regenerated areas. So this picture here of me taking a break at lunch, we're in a burned area up in Mills Canyon, which is in the Entiat Valley. And we would go out, lay plots, and basically just lay a plot and count how many new little seedlings were coming in. And surprisingly, you would think, oh, there's nothing here. This is void of any sort of life. But as you can see, there's like tiny little forbs growing in here. And there were surprisingly quite a large amount of seedlings, especially lodgepole pine, which is dependent on fire for germination. So I learned a lot there. Being from Western Washington, I hadn't really been in this type of ecosystem before. So that was kind of cool to, be a part of and learn about. We would also identify potential fire hazard zones by like defining and fuel loading, or essentially like layers of potential things that would burn during a wildfire, because of course this area is adapted to fire. It's generally low frequency, low intensity frequent fires, so usually burning everything on the ground layer. But obviously larger crown fires have become more of a problem, potentially because of a mix of warming as well as fire suppression over many years, which just has built up fuels in a lot of areas. So that can explain why things like the Chelan Okanagan complex fires of 2015 got so out of hand and ended up burning over 1 million acres and then being the largest fire in Washington state history. There's just, humans have played a huge role in the landscape, especially on the east side. So that was interesting to see. A lot of recon and collection, tending and delivery of seed cones in the second season I worked there. We did a lot of restoration, especially for the white bark pine, which has a shrinking range due to the effects of white pine blister rust, which I'm sure many of you have seen here on the west side. Western white pine is affected by this blister rust. Ribes or currant species, they carry this fungal pathogen, which is blister rust. And anytime there's like a currant bush that's planted next to a pine species, it will find a host somewhere, being a white pine or a 5-needle pine, and will eventually kill the tree. And unfortunately, white bark pine has really seen a decline as a result to this non-native introduction of the fungal pathogen. So we did a lot of climbing. We would harvest cones, which was fun. It was fun being paid to climb trees every day in beautiful locations. I can't deny that. I kind of miss that work, but it's in the past, but I think about it fondly. So that was a really cool project to be a part of. And then of course we planted a lot of trees and shrubs for animal browse. And this bottom photo is actually a picture when we were just about to start planting. As you can see, this part of Mills Canyon and Entiat desperately needs reforestation. So you can imagine some areas have been so horribly burned that restoration efforts are definitely underway and continue to be underway to this day. Here are just a couple photos of white bark pine restoration. This one, I'm up in a tree caging the cones. Same within this is kind of what it looks like after I've caged the cones. And you're probably wondering, why are you putting cages on these cones? And that's a good question. There is a jay called a Clark's nuthatch. It's a type of jay. That comes on actually forages on the seeds or the nuts. They're very similar to the pine nuts that you would purchase in the store, pinyon pine nuts. So very oily, very fatty, good sources of nutrients. So this bird it loves pine nuts, and squirrels and chipmunks also do as well. So in order to protect some of these cones so that we could actually propagate them and come back and plant them when they grew up into about 2-year plugs, we would have to cage them at the beginning there's like some different windows of time, and it's usually over just a few months where you can actually go and cage them, and then you have to come back a couple months after, just before the cones fall off, and retrieve them essentially before the birds come in and grab them once they fall to the bottom of the cages. It's very funny, but they've been doing it for decades. Apparently it's helping. Here at the bottom, this is we climbed ponderosa pine too, entered wild stands. And this just kind of shows you an idea of how we determine if a tree is like a good tree to pick from and has viable seeds. So like this cone here, you can see has multiple developed cotyledons, which are these little white parts here, which means that that's probably a viable tree to harvest from. And we would usually pick 3 and make sure that each one had at least 5 viable seeds on each half. And then we would kind of determine, hey, are we going to climb this and spend 20 minutes potentially up in there picking cones or not? So very fun thing. And these efforts are underway to this day at a federal and state level, and even private level as well. After that, I got sucked into the idea of a permanent full-time position, which Puget Sound Energy did offer to me as a contractor with Asplin Tree Experts. You've probably seen their big orange trucks all over Western Washington. They come and basically do all the vegetation work along power lines based off what Puget Sound Energy wants them to do. All the guys that are part of these tree crews, their crew leaders are all ISA certified. So arborist certification, it stands for International Society of Arboriculture, and it's a pretty rigorous test. So the leaders of these tree crews are generally pretty well informed as to what they need to do, but they have to do it within a certain time frame and under the guidelines set by PSE. So sometimes you'll see certain trees that you see like a little section cut out, and it's just like the goofiest looking thing, but that is utility forest management for you. So we worked for PSE. Basically my role for that job, I didn't do any of the actual on-ground tree work. I was more in consulting, and I dealt with landowners. So I would go talk with folks and let them know, hey, there's some trees in the power lines, they're dangerously close. And if we were doing maintenance, we would sign off work agreements, and sometimes we would make arrangements to replant species if, say, there was a tree that was growing under the power lines that needed to come down because it was a hazard. We would compensate them with plants. So if anyone comes to your door from Asplin, make sure if they want to cut down your family cherry tree, make sure they at least pay you back with a brand new tree of almost equal value, because it is available to the public, and that's something that people don't always know. And these energy landscaping booklets are really nice. If you have an area under some power lines where you're thinking of planting trees, you can refer to this guide, which you can call PSE in your region or in your area and actually get these books. And essentially anything that does out at 30 feet or over 30 feet in maturity is safe to plant under the lines. And then you don't have to worry about Asplin coming through and cutting them back. But yeah, it was a great job. I got an ISA certification with them, and it was just super different from when I'd been working in previous, more in kind of that wildland setting as opposed to an urban setting, but very valuable skill set. But I was drawn into this idea of industrial forestry and understanding how timber harvest work, because I do very much value wood as a renewable resource, and also what the state has done in terms of making efforts to kind of change the way that they approach forestry and provide revenue for the state for public schools and roads through their timber harvest. So I was inspired to go back to school and learn a bit about that. And in the process of going to school, I actually got an internship with the DNR this past summer, working for their seed program, which was fun because I had done the seed work for the Forest Service. And most people don't know that actually, since the early 50s, seed crops in the different seed zones throughout the state have been monitored for their health and production. And They do this because if, say, if a farmer or let's say a private landowner wants to plant trees on their property or reforest their property, they could reach out to the state and say, hey, I really want to reforest my plot of land. I live in this seed zone. What genetic varieties do you have that would be appropriate for this area? And the seed program or the seed orchard would say, hey, we've got these options, and they would be able to essentially provide a good portion of seedlings to plant on this hypothetical person's piece of land. So it's pretty neat. And the seed orchard itself actually has been around since the 70s. I actually don't know where the seed program was based out of. I assume Olympia prior to the 70s, but it's in Olympia today, and they developed it on an old strawberry farm, plot of strawberry farmland. So, and their primary practice there is cross-pollination. There's no genetic modification or gene editing of trees. It's simply cross-pollination of different families of trees from appropriate seed zones. So that's kind of interesting. A lot of people think there's a lot of GMO work being done there, and that is simply not the case. It's a lot more painstaking, actually. So very interesting stuff. In order to do some of these processes, they collect branches or scion, which are like the little tips of trees, and they pick trees that have these genetic traits, like maybe say disease resistance or adaptability to certain other disturbances. And essentially they take these little cuttings and they graft them to rootstock or these little root bottoms, and then they graft them on and they grow, and it compartmentalizes and then grows into these trees that produce seed that they then take to Webster Nursery and turn into little plugs that they use to reforest lands in appropriate seed zones, obviously. But very interesting stuff. I haven't actually been in the nursery setting like that until this past summer, and learned, this method can be really important, especially in a changing climate, which has been largely attributed to anthropogenic or human caused pressures. We could give back potentially by playing this key role in reforestation of state and public forest lands. So really neat stuff. Researchers also just beginning to explore how to adapt seed orchard production to changing forest ecology, like I said, driven by climate change. So a lot of that research is in the works. Some additional research, and if you're ever interested, you can always call the Meridian Seed Orchard and schedule a tour. The head silviculturist and geneticist there would be happy to take you around and show you what they're doing, and it's a really neat program. But essentially what I was doing good old tree pruning and monitoring and harvesting seed and sorting seed, as well as applying herbicide to invasive species like what is the little, there's a vine, it's like off the top of my head, I can't even think about it right, I can't think of the name right now, but there's an invasive vine that grows pretty heavily in the orchard. So because it is an orchard and everything's alley cropped, it's not really a natural forest at all, it's very much like a crop setting. It requires extra maintenance in order to protect the seed from pests. So the herbicide's kind of necessary there until they can maybe find other options. And then my graduate program that I am super close to finishing, very excited. I am doing a forest management plan for King County, and I am in, as Beck had mentioned in the beginning, I'm in the Master of Forest Resources program with the School of Environmental and Forest Science at UW. And they have this relationship with the program, with King County has a relationship where they have all these parklands throughout King County that don't have any sort of forest management plan or stewardship plan written for them. So they gifted me Big Fin Hill Park to write a plan for. This park is located in Kirkland, and here's a map showing kind of the boundary around the property. It's a unique shaped property. They actually acquired parts of the property at different periods of time. So probably explains kind of this odd shape. There's about 9.5 miles of trails for recreating, hiking, dog walking, bicycle. I mean, they have mountain biking in there. I almost got plowed into by a mountain bike, but hey, they were having a good time. So, we were good, but there's lots of opportunities there. And essentially the management objectives of my plan, because this is in a mostly urban area, as you can see in the map here, this is Lake Washington down in the bottom left-hand corner. and also having these other wooded parklands around. You have Denny Park down here, St. Edward State Park to the northwest, and then Juanita Woodlands, which is another previously owned King County woodland area. So there's a lot of continuous forest. So doing any sort of tree extraction for commercial purposes here is just not realistic at all, nor do we really want that in this area because it's unique. There's a lot of matured old trees that actually still exist in this property boundary and also in Denny Park down here to the south. So we really want to preserve and manage for more ecological reasons, which is promoting and preserving these old growth forests to improve resilience to a changing climate, which it's predicted to get a bit warmer in the near future. Whether it be from natural reasons or human caused reasons. It's been observed, and it's going to happen in one way or another. So we want to also promote carbon sequestration, because with more greenhouse gases in the atmosphere, conifer trees actually do store more carbon over time because they are longer lived than, say, broadleaf trees like alder or big leaf maple. So it's really important to protect these conifer species, which are traditionally in this area. As well as enhance wildlife habitat and quality, protect wetlands and riparian areas, and maintain opportunities for safe recreation. Let's see here. Maybe I should stop and see if anybody has any questions.
Yeah, so if folks have any questions at the moment, you can do the old hand raise, or I can see in the chat box here. So feel free to chat away as well.
Clematis. Okay. It was actually morning glory, now that I think about it, but yes, clematis would probably also pose problems for small trees. It's beautiful, but it does pose some issues.
Are you getting tech or chats there?
Yeah, I saw a chat. I was struggling to remember what we were spraying, and it was morning glory, but clematis is a similar vine species that can also be detrimental to young trees. So
awesome.
Yeah.
Cool.
I'll keep going then.
Keep it going. Yeah, thank you.
Yeah. So in the park, there are 5 different forest types that I identified after doing inventory sampling. So what you see here in blue is actually what's a mixed conifer broadleaf forest type. It composes the majority of the park. So about 197 of the 220 acres are forested, and 128 of those are mixed conifer broadleaf. So this area is mostly comprised of big leaf maple and western red cedar, with smaller amounts of Doug fir, western hemlock, Pacific madrone, cottonwood, alder, bitter cherry, dogwood, wide variety of species. And this is actually, in my opinion, the most unique forest type in the park, just because there's just a lot going on, also in terms of invasive species cover, which I'll get to later in the slide. In the purple here, these are stands that are dominated by Douglas fir. So after sampling in these areas, over 50% of the stand was composed of mature Doug fir. So very unique too, because most of the large trees or large Douglas fir in the property exists in those purple areas. And then 9 acres is characterized as black cottonwood forest type, and it's kind of in this area here, north of the ball fields, and dominated by black cottonwood as well as red cedar. There's actually a stream that flows right along this side, if you can see my cursor here, and then right along the other side. So those species are very much characteristic of wetland and wet areas. And then these tiny little red patches are pure, mostly alder stands that have high presence of invasive species like Himalayan blackberry, and will require certain management. It's really important. A lot of people sometimes forget that certain management practices cannot be applied everywhere. It's really forest type dependent. So say, for example, when we're thinking about invasive species and how we want to manage for those, in the mixed forest type here, there's heavy thickets of English holly, laurel species, Portuguese laurel, English laurel, as well as blackberry and English ivy. I mean, and it's scattered throughout, and particularly bad in this little cottonwood stand where an old historical orchard actually exists, which I'm hoping they restore. As part of my plan, I'm recommending that they wipe out a bunch of the blackberry in there so that these old apple trees that are there that were planted by homesteaders in the 30s have a chance to kind of thrive back. It can be its own little unique area. So invasive species management is something to consider because I'll actually get into that in the next slide, but it does determine what type of treatment you will apply. Common diseases are arbutus canker, Natracia mangiferi. It kind of it's just very common, and madrones are suffering from it. Again, I'll talk about that in my disease slide, but also laminated root rot, butt rot, that sort of thing, very common in Western Washington. Animal damage is another issue that they face in this area. There's lots of black-tailed deer. They love seedlings, and they clip them down to little tiny nubs until they're gone. So we got to think about what we're going to do about seedling protectors and whatnot. There's a ton of mountain beaver in this little area, and they also love clipping seedlings, and they actually store them right next to their little tunnel entrances. So you know they're up to something when you're walking through there. If you don't trip in their holes, you're going to see piles of seedlings there. Also, there's a wetland here in this oh, I skipped the willow or forested wetland. Oops, that's the third largest forest type. It's in this corner here. I believe it's, yeah, I gotta move your faces. Oh yeah, it's in orange. And there's beaver, American beaver. There's a beaver pond there. So, and as you know, beaver, they love girdling broadleaf trees like cottonwood and alder, as well as snipping seedlings too for creating their lodges or their nests. So animal damage is a big one. Also soils, terrain, water features, habitat. These are all things that you want to consider in how you're going to manage an area, because certain things like water features may require buffers, and you can't do any sort of tree removal within those areas. So lots to think about. It gets a little more complex when you're trying to work within systems where you're not just clear cutting an area and then starting from scratch. It just takes a little more thinking, but that's okay. We're capable of doing it. So as long as we are just patient and persevere. Top left, this is just some images of the different forest types. This is the mixed conifer broadleaf forest type. You see that the understory is characterized by common shrub species like western sword fern and salal. Then you have some a western hemlock here. There's some cedar in the background and a bunch of big leaf maple. What you can't see in this photo is there's a massive cottonwood just behind me where I'm taking this photo. And then you have the Douglas fir type. As you can see, lots of large Douglas fir with some madrone peeking out in the background, which madrone very commonly associates with Douglas fir. It's believed that they have mycorrhizal connections that they share in the soil between their roots, which actually are beneficial for one another's growth. So very, very interesting forest type here. Here's the wetland area, and just to the right of this photo is a beaver dam, and then the giant beaver lodge, which I wish I would have put a photo in here, but we just don't have time for that. But this is a unique area. You see a lot of senescing cottonwood. Essentially, it's just cottonwood coming to its end, or it's dying, and that provides great wildlife habitat. In the understory and overstory, you see a lot of willow species like Sitka willow, hooker willow. Just a unique area in itself. And then here's the cottonwood stand, pretty much similar to the red alder stand here. Lots of smaller, younger trees and a ton of blackberry, a lot of invasive blackberry in this area too. So just to give you kind of a visual of what these areas may look like at kind of a typical condition for each forest type. I'll kind of go quick through this since I've already mentioned it, but English ivy is a big invasive species here, Himalayan blackberry, English holly, laurels, and then there's also, scattered throughout the park, primarily I think because there's residences around the park. You'll see more things like horse chestnut, English hawthorn, mountain ash, and even some other species that find their way in, like some strange nursery varieties of yew tree, which I saw in the forest, and I'm thinking, what's going on? Oh yeah, there's houses all around Big Fin Hill, and some bird came through and dropped a berry, and poof, voila, you've got a tree. But this picture was interesting because interesting and also kind of sad. I have arrows pointing to all these different invasive species. You've got a Portuguese laurel here. You've got I thought this was Himalayan blackberry, but I think it's actually over here. But Himalayan blackberry, English ivy, English holly, all in the same area in this mixed forest stand. So you can, if you can imagine, there's a lot of invasive species control that needs to go on in this park. And again, touching on the diseases, which I'd already mentioned, you have arbutus canker, which kind of forms these bumps on branches and trunks of madrone with these kind of like rough margins. They're really like really gross looking, but they're very easily identified. And basically what they do is they actually prevent translocation of nutrients up to the tops of the trees. So that's why you see dieback on madrone a lot, because they're just not getting the resources that they need because they're infected by this fungal pathogen, the Nitracia mangiferae. And then on the right, you see some of the effects of the root disease, the Phytophthora root disease in madrone. So madrone really have it tough, and they've been declining for the past few decades in the Puget Sound area, which is sad. But, you know, maybe with the right restoration treatments, we can help them out a bit. Laminated root rot is a big one. Normally this happens when forests start to age, or after logging events. You get these big gaps in the canopy here, and then you can see around the edge of the canopy opening, there's a lot of defoliated or dead Doug fir. And usually there's like one source tree, and then it kind of spreads out and creates these gaps. So managing for these areas is really important. And it's usually a good idea to plant species that are rot tolerant to laminated root rot or the Coniferporia sulfurcescens pathogen, such as like red cedar and hardwoods. They can pretty much withstand. There's not a problem for them. So that's general practice in Washington, is to plant gaps with those kind of trees. Also Schweinetzii butt and root rot. This is a fruiting body, or also known as velvet top fungus, which I'm sure you've seen around. It's one of the most common butt rot or root rotting diseases in Western Washington. And it usually, these fruiting bodies or these big fungi grow at the base of old trees. And this generally isn't a big problem because they don't typically topple trees unless, say, it's a big windstorm. But, you know, generally trees will persist for a long time before they uproot and fall over. But it's really important to consider, you know, if there's trails or public areas nearby, you're definitely going to want to maybe lower the tree, cut it, especially if it's at the end of its life, and keep it as maybe like a wildlife or a habitat tree, rather than falling onto someone's car and potentially killing and causing some serious damage to somebody. So these are things to think about when in the forest. I also want to touch on top dieback of red cedar. It's uncommon in the park, but I'm sure you've seen it around. Cedar dieback has been happening where the tops just kind of turn into these really crusty, rusty looking, not healthy looking crowns. And it's assumed that it's caused due to the drought period that we've been going through. And different years, you know, you have hotter summers. So it causes a lot of water stress, and it too, like the arbutus canker, it reduces translocation of water, which carries the nutrients up the sapwood. So it causes cavitation essentially, which causes this like air gap that forms in the sapwood and causes this disconnect, hydrologic disconnect, where water that carries all the nutrients from the roots can't get up. And then you have this top-down effect. So top-down dieback effect, excuse me. So arborists in the area are currently trying to figure out the best ways to manage for this. But again, not a huge problem in my park, which was great because there's a ton of cedar. So it's really good to see that a lot of the cedar's thriving. And then last about the plan here, you know, my management, the way that I'm going about it, because most of the forest is in mature to old growth, mature to an old stage in development, or in that understory reinitiation stage. I'm comparing it to a no management scenario, where basically my management treatments involve creating gaps and treating anti-gaps, which are areas where, say, invasive species have dominated and created these gaps where natural vegetation would otherwise be. So in the gap areas, we're going to be, they might range anywhere from 5 to 3 acres, and trees that are maybe unhealthy, like if there's a ton of madrone there that are just totally not doing well, and are at the end of their life, or say like red alder, senescing old red alder, we would clear those areas, treat the areas by doing mechanical removal to give the new planted species room to grow, because shrub layers do grow back very quickly in Western Washington. We just have the right conditions for it. So we have to treat those areas so that the trees actually have a chance to get big. But basically planting a bunch of conifer species in there to kind of promote the forest, to kind of go back to those older conditions where, or natural conditions. They're beneficial to the forest, not only that in that it provides different age classes within the forest, which creates structural diversity, but also stores carbon over time, because conifers are longer lived than broadleaf species and can store vastly larger amounts of carbon over time. So the way I thought about this is most of the gaps would be created in the mixed forest type and the Doug fir type, which account for 86% of the forest there. And they're also further away from like play areas and athletic areas. So it's maybe more appropriate to do these treatments. All the trees that would be cut in those gaps would stay on site to act as legacies in the area for decomposition, because decomposition rates over here on the west side are very high, which would only help go back into the soil and promote carbon into the soil for decomposition and nutrient cycling. Also leaving legacy trees standing, so big trees. Every acre, it's probably good practice, and this is DNR practice as well. Every acre that you cut, you actually want to leave about 3 legacy trees that could provide good habitat for animals, so or seed sources, and then those would be living. And then you have 2 standing dead trees that would primarily provide cavity nesting for birds or other rodents, and then 2 downed logs. Clearly, we're going to have plenty of down logs. So kind of trying to follow the state-based policy that's in effect. And then again, these gaps, they emulate older forest structure, which this forest is moving into that structure. So that's why I thought it was an appropriate management option. And it does mimic natural gap creation that takes place at this age, and as a result of disturbance. And in this case, we're causing the disturbance, but the idea with ecological forestry is that it mimics natural disturbance. And again, creates a wide range of habitat, including successional, edge, and mature forest, all in one stand. And it restores the stand to natural conditions for forests in the Western Hemlock Zone, which have kind of shifted their natural conditions because of logging. So all this forest is second growth. And back in the day when they were logging areas, they weren't necessarily replanting them. That's why you see a lot of areas that have regrown with broadleaf trees and they persist over time, where there should be conifer historically. So that's my thinking there. We're getting close to the end, guys. Thanks for bearing with me. After I graduate, I have actually taken a position with the DNR as a state lands forester down around Mount St. Helens. And I really like the DNR. I just put their mission in here. It's to manage, sustain, and protect the health and productivity of Washington's lands and waters to meet the needs of present and future generations, and to sustain long-term ecosystem and economic viability and foster resilient forest lands and the benefits derived from them. And I really like what the state has done. They've set an example for a lot of other state forest practices across the nation that don't necessarily enforce the same sort of regulations or progress with scientific research over time. I think that that's really important, especially because we want to have these resources available in perpetuity, because forests do provide natural resources that are renewable. And it's, if we can do it in a less impactful way while still creating revenue, particularly for the state, which goes into funding schools and roads. For example, you know, it's good to be able to do this sort of management that maybe isn't as invasive. And clear cutting, you know, in certain areas like in the coast where areas are more moist and flat, clear cutting actually with buffers in place for streams, clear cutting is not as harmful there as it would be, say, on a dry slope immediately west of the Cascades. So that's another important thing to think about too, is certain types of forest extraction or harvest. It, you know, when you're thinking about where to apply those, it really does depend again on site conditions and just understanding that certain practices don't really work everywhere. So I like that about the DNR. They have opportunities for us to go in and make these things work out in a way to preserve the area and also provide resources and revenue for the state. And I won't go over this last bit here, but this kind of goes over what I borrowed for my management is to leave 3 wildlife or reserve trees, 2 down logs, and 2 green recruitment or seed trees per acre. And if you're interested in reading forest practices, some of you might think, oh, this sounds boring. And I don't blame you, it is a bit, but if you're managing your own land, for example, it's really useful to check this out. Here's a link. This is recorded, so you can access this on DNR's website, and it kind of gives you an idea about what the DNR expects or what they recommend, for managing private lands in terms of leaving buffers around streams and wetlands and that kind of thing. 2 more slides to go. Just briefly want to go over my basic field tools that I use. I have a big old orange vest. Actually, it's right here. It's a big clunky thing. I take it into the field. I put my lunch in the back. I've got all sorts of tools filling my pockets. It feels like I'm carrying a small child, but it's all good. And in my vest, you'll find a compass that gets me around. We do have phones and tablets that we use to get around the woods, but we do definitely rely on a compass still. You always want to keep that with you. Field notebook to take any notes about things that might be interesting while you're in the woods or notable things. Your diameter tape, which is specifically made to measure the diameter of trees at breast height, which is about 4.5 feet up from the ground on the stem of the tree. And they try to keep, they keep it consistent so that there's no variability between measurements. A laser rangefinder, which measures tree height, an increment borer, which is a long stick. I actually have it up there, but you might not be able to see it with my background. It's basically a long stick that you put this big old metal pipe in it, and you bore into the tree, and then you have this little spoon, you stick it in, you pull it out, and that's how you count age rings on a tree and kind of get an idea about age distribution in a stand. And that's a really fun tool to use. It really does help make you maybe a bit stronger. It's hard work sometimes. The clinometer, which is used to measure slope or percent slope in certain areas, which is also important to consider in terms of like drainage, even aspect, that's where the compass comes in, kind of gives you an idea how hot it might be on a given slope, which determines how you might want to plant an area and with what kind of species. GPS tracking devices and 2-way radios, those are all very common. Also my PPE, my protective equipment. I have my vest, which I just showed you, hard hat, which can be a pain to wear, but it's better to have a hard hat in the woods and not get, your head smashed in by a branch. Fire rated boots, if you're working on the east side, those are very important. Basically, if you were to step, say, in a big burned hole, it would protect your foot from getting burned. Cork boots, which are spiky boots that help you grasp onto fallen logs, especially in wet areas like Western Washington. If you're wearing your fire boots, you're going to be slipping around and maybe break your ankle or something. Eye pro, gloves, whistle, bear spray, that sort of thing. We are sharing the woods with wildlife, so sometimes you got to whip out the bear spray if you're getting harassed. And then common measurements, again, diameter tape. We take breast height measurements, age, basal area, which is a metric for density in a stand. It can tell you whether or not there needs to be a thinning in a particular area, or just gives you any kind of density metric. And also stream typing, that's a big one too. Basically, if there's a stream in your unit, you want to know if it's of the size to hold fish or not. So all things to consider. And when I sample, I use plot sampling to collect stand inventory. And you can see there all the things that I do there. Computer programs, basic stuff, Excel, Office, ArcMap, which got to make a lot of maps in this job. And then the Forest Vegetation Simulator, which is available on USDA Forest Service website. And that just models the growth of forest density over time based on your data that you collected. And last but not least, I want to leave you guys with a thought about future forest health and climate change, and just maybe what that might look like in Washington. Studies for almost the past century have been, looking at how warming has changed, and there's been cooling periods, warming periods. That's just generally how, climate works on a geospatial timescale. But generally from what has been observed and statistically analyzed, we are expected to have drier, longer summers with warmer and wetter winters, which we have already started experiencing. A longer growing season, people think, oh, great, that's going to be great. It's going to help all of our vegetation grow better and faster. But the onset of these summer droughts that we've have already started to see will limit plant growth and increase stress. It's also really hard to predict how an abnormal growing season will affect the timing of flowering and reproduction in trees. So for example, like trees in alpine areas, if it's warmer than it should be, just like any of you gardeners out there will know this too, if it's warmer than it should be and a frost hits, that could be very damaging, especially if trees start budding early. So that's happening in alpine areas specifically, with subalpine fir. It's hard to predict too how it will alter plant and pollinator associations and maybe change seed dispersal by animals and affect even other interspecies relations. So these are all things that we want to think about as foresters and forest managers. In the way that we plan. Douglas fir is likely going to be the most adaptable because it's the most drought tolerant, especially along the coast. Most coastal species will probably, if anything, maybe thrive in this warming climate, but everything more interior may struggle a bit more under drier conditions, maybe where it's less moist. Drought effects will likely hit like hemlock and cedar and madrone the hardest. Most likely hemlock, they're a little more sensitive than red cedar, especially when red cedar's understory of conifers like Doug fir. Higher elevation species may also succumb to frost damage, like I said, from the early onset bud burst. So it's generally good practice to plant conifers because they're longer lived, natural to the landscape, store more carbon. Even big leaf maple is pretty good to plant as well. They do pretty well with drought because they're the way that they're broad leaves, so they actually they hold more water in drier seasons, which gives them an advantage. But under hot conditions, they won't do well either. Mixed species forestry is also becoming more popular. Instead of just planting pure stands of, say, Doug fir, they're experimenting more with mixing species, which can also promote resilience to climate change and prevent the spread of insects in stands and the effects of them as agent mortality or causing mortality in forest stands. And then last thought for the evening, and DNR is actually taking steps to develop plans for adaptive management. And that is the basic idea with adaptive management, is that you will take the measures necessary to promote forest health in terms of like resistance to stress, resilience, and responses to the effects of climate change in a positive way and not so much a negative. So adaptive management, it's believed to reduce the risk of catastrophic loss to forests, and it really just involves more monitoring of forest areas, especially areas where we're going to be entering more frequently. So state lands where we know and expect when we're going to enter an area for a rotation or a harvest. So keeping up with those areas, the Forest Service is doing it too. It does cost money, but LiDAR technology and satellite imaging technology is becoming very cost effective in monitoring the overall health of forests as we enter on into the future. So with that being said, I thank you so much for hearing me out tonight. And yeah, do you have any questions for me?
Thanks, Kayla. I had a question.
Yeah, sure.
Sorry, I'm skipping over Ed. Ed was wondering, after reforestation work and in light of climate change, how do you ensure the viability of the new trees that are planted?
Mm-hmm. Yeah, so that's a really good question. Honestly, that's, we do rely on these seed programs a lot of the time, and finding good seed for a particular site can be the most challenging. That's why I'm a big advocate for seed programs. We do have natural seed banks in areas. So one strategy is to just plant a high amount of trees in an area because that there's an expected mortality of seedlings. So by planting more trees in an area and then thinning 10, 15 years after, depending on the growth rate of the tree that you're planting there. So if it's Doug fir, you'll probably do a thinning to release some of the more strong overstory trees that have competed better. So that's one way to ensure the viability, is just to do these follow-up thinnings and just plant high numbers of seedlings. And it might sound wasteful, but in the end, if trees do die, which they will, once they reach that canopy closure stage or that competition stage, it will go back into the soil and provide a source of nutrients. So that's, I hope that answers the question. It is tricky, but yeah, general response is just to plant high per acre and account for mortality that way.
Yeah, that reminds me of when I was in restoration, we talked about madrone smoothies. So just like collecting madrone berries and then spraying a slurry on the landscape, and the seeds would, self-select for their conditions. So. But I had a question about, yeah, it was pretty fun. To what extent are the fungal infections that you went over like naturally occurring, and then like are they amped up because of their activity?
That's a really good question. So I don't know the specific research that's gone into that. I do know that a lot of with older forests, you do naturally see those diseases coming in because trees, they weaken as they get older. They're not as able to compartmentalize wounds. So they're more sensitive actually compared to younger trees, which you think older trees seem more resilient. And in ways they are. But if you were to cut off a huge limb on an old growth tree, it would probably succumb to some sort of fungal infection, as opposed to say like a 3-inch diameter sapling. They don't put on as much volume in their old age. So that's kind of it's to their detriment in that sense. But yeah, I mean, humans definitely spread spores. I mean, even walking in the park, I kind of attribute the fact that so many madrones are dying because there's so many trail systems weaving through the park. And if somebody walks in an area where there's spores on the ground and tracks them through to other areas with madrone, that's how it spreads. It spreads from tree to tree. And then if a tree, let's say, has a mechanical wound or has any sort of area where a fungus can enter in and the tree can become its host, it's kind of, I think definitely humans play a big role in spreading at least fungal pathogens and spores. Also, it can be argued too that with warming climates and us and industry pumps a lot of greenhouse gases into the atmosphere. That's undeniable at this point. But with warming conditions, it just makes it more likely, say, for bark beetles to infest certain areas, especially if you're planting pure stands of one species that is susceptible to bark beetle. And then you have a drought on top of that. You can definitely attribute human activity to, I think, in my opinion, maybe there's no hard evidence, but there is assumption at this point. So yeah, I think humans definitely, and it's not like we're trying to do it, there's just a lot of us on this earth, and that's just the way, unfortunately, it is. So that's where I kind of come back and ring true to this idea of adapting and just trying to help the forest to become more resilient, because we're not going to stop harvesting wood. It's a renewable resource. We build our homes with it. We use it for paper bags. We even use sawdust in dairy products, believe it or not. You can look into that. I mean, it's wild. There's so many uses for wood products out there. So yeah, definitely good question, Beck. Humans and natural conditions alike.
Right on. Well,
Yep.
last call for questions for our friend Kayla here. Anybody else got a thought or a question they'd like to ask? And as Kayla said, this was recorded, so there's a lot of really interesting information in there, so you can definitely go back and rewatch and check it out. It'll be up on our YouTube page in the next couple days here. So, well, Kayla, that was very, very interesting and fantastic. Thank you so much. I've gotten a couple messages, both in the public and private, that people were just really intrigued by it all and very happy about it. So thank you for taking the time. It's great to have you here.
Yeah, I like talking about the woods, and just I'm passionate about it. So I'm honored that you asked me to come and talk about it and just give my perspective. Very fun. Thank you so much for having me.
Yeah, our pleasure. And we'll take you out to the ACFL when you come visit.
Oh yes, I will be over soon.
Right on. Well, folks, that brings our evening to a conclusion here. I just can't thank you enough for joining us tonight. I cannot wait till we can do this in person and be together. And, we're starting up community hikes again soon. And we've been doing kid programs. And it's just like, it feels like there is a light approaching at the end of the tunnel here. So we just can't wait to be with you. One thing I forgot to mention, our hope and our goal this year is to have our benefit in November happen in person so we can all be together and celebrate again. So we will definitely keep you posted on that. Meanwhile, keep an eye on our website and keep an eye out for all the fun things that are going to be coming up and all the great programs that are going to be happening. And please get in touch if you have any questions or thoughts or anything. And we'll see you in the forest. Bye, all.
Bye. May the forest be with you. Thanks, Kayla. Thanks, Isa.
Our pleasure.